right. Hello, everybody. Welcome back. Glad to see you here. How are we all doing tonight? I am hoping that I got everything working again. You know how it goes. Everything's kind of a frantic run around, getting things together before the show starts. Tonight, my show notes are a little bit sketchy, but this is supposed to be a fun live stream that's more based around different kind of charging techniques, things that I do that I probably shouldn't do, things that you can do, different ways of charging, and just kind of generically figuring out how to make the most out of it. Don't know how many we have here tonight. Let's see if I can switch over to a chat window here, see if anybody's around. How are you guys doing? How is everyone tonight? There we go. All right. And I just want to double check and make sure that I can actually bring the chats up tonight, and I can. Everything is working. Good to see you guys. We have had a packed week of those. For those of you who know, we've got all kinds of videos coming out and all kinds of videos there, even with the Christmas holiday and with the solar class launching at the beginning of the year. So I've got a lot of work still on that one that I'm putting together. A lot of the unique content is going now, so that's been really fun. A little distracting with the new solar shed videos coming out, and then I think it was this morning I posted one on battery code violations. That's what it was, code violations. That was a fun video to make. For those of you who have been watching, I put a bunch of wire in the solar shed for PV and realized I had a major code violation. Thanks for the personnel who pointed it out. I do have two different mics hooked up tonight in case I run into problems. This is not the mic that I'm using. I'm actually using this mic, and I'd heard that it sounded much better. So I'm going to use it tonight for the majority of the time unless I turn around to work on the board over here. It looks like the audio levels are pretty good on it. If I turn around to work on the board, then I will switch to this microphone, and this allows me to move around and not have any loss of quality regardless of which way I'm pointing. But I hear that it doesn't quite sound as good as this mic. So I will just leave them both connected in case I run into some problems with one, and we'll do it. I did find out that a lot of my problems have been caused by a USB power station thing that I had bought, and it was not working all the time, and that's what was going on and why I was having so much trouble with all my equipment. So looks like this week everything's functioning and working, so let's get on with it. I want to start with I usually save this part for the end, but I want to start with a real shout out to you guys for the subscriber count right now is sitting at 17,619. I usually save this to the very end, but I want to celebrate early on this. It is Christmas. You see my Christmas shirt. I want to say thank you to all of you. You have been so gracious, and it's so good to be a part of this community. And I'm hoping that for years to come, we'll be able to grow together, to build bigger and better systems. And tonight we'll talk about some of the crazy charging things that we do to keep your batteries full, with yesterday being the winter solstice. Yesterday? Yes, it was. That was the smallest sunlight day of the year. Surprisingly, today I am sitting at, and I think I could probably show this to you pretty easily, let you guys see my new home assistant. I just kind of started building this one and throwing things up here as I started working on it. So you can see here, I am sitting at 97.5% right now. Today I did make it all the way right up to the edge of 100%, not quite 100%, but that's because I'm using some of the techniques and some of the processes and techniques that I'm using that I'm going to talk to you today about to make that happen. Now, I've got a variety of them, and I encourage you guys to point out what techniques you use, which ones you like, which ones you don't, and then I will go from there and just kind of expand on it. NSB says congratulations. That I'm sure that is for the number of subscribers, and that is congratulations to all of you guys. Thank you so much, and especially the members and the subscribers. It's really appreciated. We've just been growing gangbusters, and it's been a wonderful, wonderful ride. I can only hope that it continues the same as it is before. So let's start off by talking a little bit about, unless anyone's got specific subjects that they want, I encourage you guys to comment, butt in, change the subject, twist things upside down, have a little fun. I can make a video anytime that doesn't involve, direct communications, but the fact that you're here and you're watching, that's the part that it interests me about having, what are we calling these? Live streams. So that's the part that interests me about having the live streams, is having you guys around for them. So I encourage you to support and, well, not necessarily support, but encourage you to participate. Make it fun. Even if they're jokes, I'm okay with that. We'll have a lot of fun. And so this week, I want to start off with talking about normal charging and those different techniques that we have, so that we can get into some of the crazier things that I've been using. As we saw, I'm sitting at, that's not the screen you want to see, is it? I'm sitting at, 100% out in the solar shed. I've been running the coffee trailer and all of its refrigeration, not just its normal freezers, but I've been running the refrigerator too, keeping all the sodas cold, keeping all the milk cold, because there's a lot of Christmas events that we were doing that are all piled up. And you can see that over here in L2, I believe, is where most of that's been running. So it has some decent sized spikes and stuff that go on there. And then in L1, we have a lot of the standard refrigeration, the freezers and that type of stuff that just runs on a consistent basis. So, but the normal technique for charging obviously is going to be one of two ways. Most people use either the standard grid hooked up and they have, just a standard time to charge. Now, I've used this method when I have a hurricane coming, or there's big storms in the area, or I'm just too low to be comfortable. The grid is the purpose for having, in my case, a lot of it is the purpose for having the solar system, not necessarily the backup system for the solar system. So using it to charge to prep for an emergency event is, in my mind, a really good idea, but I don't think it's necessarily what I would consider the ideal way of charging. The ideal way of charging, and most common for solar systems, obviously, is to use solar power. So that is going to be where you have the solar power coming in, like this chart here represents today. As you can see, I had a pretty decent early on day, but then we kind of around 140 or so, it really started to die down. Now, keep in mind the solar shed's panels are not that of a spectacular setting yet. I have 3 series of 5 panels, 250 watts apiece, running on the Victron charge controller. And then I took today and yesterday, I took another 8 panels and laid them in front of the solar shed on the ground, just to kind of see how much I could actually pull from them. And you can see that that's here under this Lux Power. Those are going in through the 6000 XP, and I've been using this to charge. And you can see that pretty much taps out there at 700 or 800 watts. And today I did notice that there was a little bit of potential there, that I had some panels laying where there was some sun being blocked at certain times and things like that. So we work that. So but these are the 2 real typical ways that you would see things being charged. Now, as a backup. And we're going to take this to the next level and talk about backup charging. And we use the grid a little bit for preparatory backup charging, but not really backup charging. In other words, when the crap hits the fan, how do you get charge back in your battery, especially for those that are off grid? When you're off grid, you don't have the grid to, and I truly mean off grid, meaning there is no grid, not meaning it's there, but you don't use it. Like in 6000 XP is an off-grid inverter, and therefore I have the grid available, but I just don't use it. I'm talking about truly off-grid, a cabin in the woods, a house in the woods, no actual power connections of any kind, no grid available at all. So the backup for me can be grid power or that type of electricity. Now, it just so happens my house is also grid tied solar. So, and it's zeroed basically. I couldn't possibly use all the power between the two at this point to make my electric bill show something, at least not this time of year. January and February, I probably could, because the electric company keeps a running balance from month to month on my grid tied system, and all the credits pile up from the summer months to cover any of these winter months. Now, when January rolls around, it's usually a close call. I haven't seen a bill yet, but the last couple of years, it's usually been pretty close to the generation and the usage are neck and neck. And my usage has been just a little bit below generation. And then once summer hits, it covers me for November, December, those type of months without ever even thinking about it. So that's kind of one option for backup power. Commonly, though, another option for backup power is going to be people who use generators. Generators are probably one of the safest backup forms in that you can pull in a lot of power. Now, let's talk about a couple of different techniques, and I'm going to flip these mics over. And please, guys, if you have problems with the quality and the sound at any point, let me know where that was so I know which mic is actually better than the other. So I'm going to switch over to this microphone so I can go over to the whiteboard. But when we're talking about a generator, there is a couple of different ways that you can charge. And the way that I use a generator and the way some people use a generator are completely different things. Some people turn on the generator and they use it like it's just a grid, and they do some charging and they do the operations of their system. So you have your solar system here, your grid flows in, and you run power to your, what am I trying to say here? You run power to your devices and you charge. So now, in my mind, if I'm doing this way from a solar, I may do it because the 6000 XP, if I'm using the 6000 XP and I'm traveling, I may do it this way simply to divert all of the power that's coming from here into the charger. But I found that a better way for me to do it is to divert all of the, not grid, it's generator. Sorry, guys. Divert all of the power straight into charging or into the bus bar, and then allow the inverter to handle the other piece. And what I mean by that is you have your inverter here, you have your batteries here. Let's see if I can draw a battery. It's not bad. And then you have your load over here. So this inverter is going to pull from the DC bus, and it's just going to use whatever power is available to run here. If you have solar panels feeding into this, let's say you have some PV feeding into this, then you could also use I did a video on this weekend, the chargeverter, and you could use a chargeverter from a generator that would in turn put that power onto the bus. The excess power would go to the batteries. The excess power would go to the batteries, and it would allow the 6000 XP or your inverter to use whatever power you have that's above and beyond from here. So if I had a large amount of power coming in PV and a large amount of power coming in from the charge inverter, this would allow these two to just feed all my DC devices together, and I don't have to worry about the dirty power coming from this generator. And this is what I'm getting at here, is that if I run it in this form, I have to worry about the 3% harmonic resonance that's required for an inverter to have that clean power that's like on a grid. I also have to worry about being large enough to provide to all of these loads all of this power and all of this power at the same time, or it overloads my generator. And that means that these spikes and stuff that come from loads is going to affect the way my generator reacts and has to do it. So what I prefer to do in this case is I prefer to take the generator, and let's say that we have a 5,000 watt generator. Then I am going to use this at 80%. And that means that I'm going to pull 4,000 watts of power, set the charge inverter to pull 4,000 watts of power and push that down into the DC bus. Now, what this does is this allows the generator to work at its maximum performance. It means it's going to get its best gas mileage, for a lack of a better word. It's going to get its best performance, meaning it's going to produce the most energy for the gas that it has. But at the same time, it also allows the generator to run for the least amount of time. And that's because it's pulling all of the power at once and placing it into the battery, the excess, but allowing me to operate like normal, have normal loads, not worry about what gets turned on and off here. Because if these combination of these two is low, then it would just pull from the battery for that few seconds and then switch right back to go back to charging and everything. So that's the helpful, the more, in my mind, this charging technique is more helpful than doing it this way. Now, I'm guilty of using this when I was in a pinch at one point. And instead of plugging in all this, my charge inverter cables weren't hooked up. And so I just plugged it right into the 6000 XP's 50 amp plug. Generator couldn't provide 50 amps, but it provided about 28 amps. It was a 9200 Predator generator, one of the quiet models, but I did turn it up to charge at 5,000 amps and to run my loads here. Now, had I had loads in excess of 4,000 watts, then I would have ended up with 5,000 watts here, 4,000 watts here, and anything over that could have caused me some problems. But provided the fact that the 6000 XP only provides 6,000 of output, it was pretty safe. I had to just be careful not to overload the inverter, which that problem exists all the time. So the solution in my mind still, though, is to use the generator as good emergency backup, but to ramp it up to its most highest performing levels, which is usually approximately 80%. Also, the generators, this allows me to use cheap, inexpensive generators. So if we were to go out and look at what, let's see if I can pull up Harbor Freight, let's say. Harbor Freight tools. And if we were to go out here and look up the Harbor Freight, there we go. If we are to look up generators, let's start with generators. So here they have this 13,000 watt generator for $1,299. But you'll notice here, it doesn't say inverter generator anywhere, which means that it's not going to have that ideal, perfectly clean fuel that perfectly clean 3% harmonic distortion that you would have on another generator. So we come down here to the specifications, and it's going to be running as noisy as all get out, and it's going to be, let's see if we can find it. Gas 7800, natural gas, propane, gasoline, Predator, 12 volt, blah, 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 blah. 78 decibels. Woo! And that's at 50% load. So as you put a little bit more load on there, it's even going to be more than that. But you'll notice here, nothing here talks about harmonic noise. And that's because it's a very noisy generator, and it fluctuates as the speed of the generator changes. So when you start this generator, it's going to ramp up to a noisy level, and it's just going to stay there. And either you use the power or the power gets wasted. So my suggestion is, on a device like this, is that we use that power by running it this way and pushing to that battery directly as a backup source, as opposed to just turning the generator on and then kind of waiting for PV and kind of stuff to charge. Okay, that's kind of the normal usage of charging, and that's kind of the backup usage for charging. There's a lot of people that use, so let's talk about some of the oddball ways of doing it. One of the ways I use the last couple of days, and a lot of you guys know this, and it's probably not the most, see if I could switch that to that and that to that. It's probably not the most efficient way of doing things, but as you know, in the solar shed that we have set up today, we have a 48 volt battery system with a 6000 XP inverter. Eventually we'll have another inverter on there, a 3000, the Pikachu unit. I'll get that one hooked up also. We'll get that one commissioned at some point. This one has a Victron charge controller with, as of today, it had 15 panels in 5S3P running into it, and each one of these is 250, so that's 1250, so it's like 3750 watts of power feeding in here. Now it doesn't get anywhere near that amount of power because 5 of these panels do pretty decent. They're leaned against the front of the shed facing due south at probably about 45 degrees angle. And then the other 10 of these are leaning against the fence, pointing east. And so they get afternoon, but there's also a big truck parked next to them. So as the afternoon goes on, these start getting shaded. But there is some times there in the middle of the afternoon where these do pretty good. And of course, we're talking about, this is the dead of winter, or dead of Florida winter, I guess I should say. You guys up north are ones getting the real winter. I have fake winters up here. My dead of winter was 74 degrees today. Sorry to show you, to say that. But this so we had this system here, and it feeds this. Now I also added in 6 more panels, 8 panels, at an 8 series at 250 watts apiece, which means this is another 2000 watts of power going in from these panels here. And that's feeding up here. Now these are laying flat on the ground. They're shaded in the morning from the shed. They're shaded in the afternoon from the house. But there is a couple of hours, as you can see from these stats here, there's a couple of hours here in the middle of the afternoon. Where did my stats go? Where did my stats go? Okay, here they are. So you can see here there's a couple of hours in the afternoon that these are, what, this one here, there we go, that these, you know, from about 10:40 in the morning when that first bit of shade gets off of them until the afternoon, right around 1:30, there's a decent amount of sun coming through here. And we'll find out really over the next few days how much that really is, because I've been out there shifting them around, trying to move them out of the early sun and the morning sun, get them in just the right spot where I can get the earliest point where they hit here and the latest point where they hit there, until the guy comes by to mow the grass anyway. And is that microphone actually working? Yes, it is. Okay, sorry. So that is kind of where all this power comes from. Now, this, I want to run a couple of, I've had a lot of requests for people looking to be interested to find out if we could do any Bitcoin processing. So I'm going to hook up a couple of bit miners and just see what kind of, I've got the extra power. They're not going to cost me anything to run, but I may order one of the big A19 Bitmain miners just to kind of get an idea. Now, keeping in mind that miner can pull 3,500 watts just to run at full speed. So we may end up having to tune it down, and we may have to just run it for some hours during the day. But that's what brought up this subject of where can I get the most power from? Because in addition to this, as we all know, I've got a 24-volt system running off of a Victron charger, has two 370 watt power panels. Now this is a 20 amp charger, so it really only has about 570 watts of power that it can provide at any given time. But for all practical purposes, when this trailer is here, I plug it into either here or to the house. And that power, then this system sits and charges. And the reason I do this is that this is great for an overnight emergency where I'm parked somewhere, or it's great for I need to get from here to a show and it's an hour away and I don't want refrigeration off. It's great for a lot of things like that. But what it is not the ultimate solution for is basically running off grid all the time. And the reason being is I've only got 100 amp hours of power here. So 100 amp hours of 24 volt power is still at 2.6 kilowatt hours or so. So it's a decent amount of power when I get back from a show and this has a day or two to charge up, or if I've used it that night, it gets charged up. The thing is that I don't want 2 kilowatt hours of power and these solar panels sitting there doing nothing sometimes for weeks on end. So what I did is in a video, I think it's coming out. When is that video coming out? Or is it out? Did I already put that video out? I'm losing track of my own videos now. Let's see. Let me go back and look real quick. It is, one of the members probably knows. Oh no, it came out. Nope, it doesn't. It comes out on the 25th. It's a Christmas release. So what I did with this one is I basically hooked up the charge inverter and I did it this way. And let me make that another color so we can kind of see what it is. So I hooked up the charge inverter to take from the inverter here, which is 2,000 watts. And I connected this to the charge inverter. And then I fed this into the 48 volt system over here. Now, that in itself wouldn't be enough, because in order to keep the monitoring equipment and everything running on, it runs off of this battery over here. So what I don't want to do is just run this until it dies and then not have any way. So this now is monitored here. As you will see, I use the automation from Home Assistant to turn the wall plug here, automation wall plug, off and on based on the battery charge of this battery over here. And this allows me to know that, first of all, the system is here and it's in my yard and it's charged, because it's completely disconnected otherwise. There is no, other than the Victron ESP32 that connects to this and logs the information and sends it to my Home Assistant, which you can see that information on the screen over here. Keep in mind, I've just put together a lot of this. So this is the coffee trailer's battery. So it's sitting at 26.59 volts right now. And it took in 2 kilowatt hours of charge today, which means it will be full tomorrow. And when it hits full, what will happen is this, and by full, let me show you the automations that I have here. There's 2 simple automations: turn off the charge inverter, turn on the charge inverter. So the, oh, it was interesting to see that. Where was I at? Oh, here they are. So turn on the charge inverter basically says when the coffee trailer's battery is over 26.8 volts, meaning that it's reached that higher capacity. Now, the idea here for this, for me, was don't let it wait till it sits at 100% and stabilizes and I lose additional production throughout the day, to go ahead and discharge it down to a reasonable amount. So what will happen is this will in turn turn on the plug that charges from the charge inverter. The charge inverter would take that energy and transfer it over to the 48 volt system. And then when it is done, turn off says when the voltage drops below 24.8, and I may need to raise this just a little bit. I noticed there is on that bus bar, there's a little bit of voltage sag where it reports that it's shutting off earlier than it's supposed to. So I may have to change this around a little bit, but then this shuts it off. This allows me to drain this battery and to put that power back into the 48 volt system and then let it charge back up and then drain it again without there being you know, any type of real connection other than a 120 connection. Now, is it ideal? This is always the argument that I get from folks when I mention doing things like this is, well, there's more efficient ways. Yes, there is. If I want to take apart my coffee trailer every time I park it in my yard and I want to hook up some fancy different devices and all that kind of stuff, then yes, there are. But if all I want to do is plug it into something and have that power transferred over, knowing that there is going to be a certain amount of loss, sure. There's a loss here when this charges and places the voltage into the battery. There's another loss when it pulls it back out. There's another loss when the charge inverter changes it from the 120 here back down to 48 volts and puts it over here. So there are losses, but that's no loss compared to the 2.5 kilowatt hours of battery power that sits there and does nothing from day to day simply because I didn't use it at all. Now, the idea is that I want to be able to power bit miners. And if I can power bit miners from this system, then I need to be able to get the power into that system, not run around plugging things in and plugging things, you know, unplugging them all the time. Could I get a bit miner that uses the power from just this system and I plug it in instead? Yes, I could. But what I want to do is I want to focus on building that over in this side over here where I can focus on building one big, nice bit miner that I can, invest in, as opposed to a bunch of little bitty bit miners and the home size bit miners that you build, that are $100 and you get 1 terahash. I want to do several hundred terahashes of bit mining when I'm doing it, and then figure out how I'm going to get enough power to do that. Now, keep in mind, last year, I bought on the upside of 50 solar panels for under, 15 to $10 to $15 a piece, depending on which deal it was. So I have tons of solar panels to still put in and to figure out where I'm going to put them. And hopefully over the next couple of months, we can get a little bit of a privacy fence up, get more solar panels installed, and start feeding in more and more power to this so that we can change the way this works and feed enough power in there to run something of that nature. But running something of that nature is very power hungry, and a lot of people don't realize that we're talking hundreds of dollars a month in power. If that thing runs at 3,000, let's say 3,200 watts for an operating, standard operating. Now you got to remember, a bit miner, when you get it set up and it's running at a certain power, it runs like that nonstop, just constantly day in and day out. Now you can tone it down and you can tone it up, and you can, I can get it to run at 2,800, or I might be able to get it to run at 1,500 or something along those lines. But once I get it to that, when it's on, it's on. So I'm going to want to be able to automate it to where when it comes on, that I can try to get it to where it can stay on for as long as possible, so I'm not turning it off and on and off and on, or have enough battery power to store it. Now, this system currently, as it stands, is 400 amp hours, or approximately 20 kilowatt hours of battery power. So it has a pretty significant size battery in it right now to handle that. And I hope to expand that sometime next year. I really want to get a hold of some of those new batteries that the guy out, the MB56s. I don't know if anyone's seen those yet. Those new MB56 batteries are battery cells are just crazy, and they are going to allow us to have 600 amp hour batteries, or the equivalent of what I got here is 400, one battery with 32, 33 kilowatt hours all packed into one battery. They're pretty cool. So I really want to play with those and build one of them. So that might be a way to do it, is to have all these systems feed into there. Now, as you all know, I do a lot of battery testing for 12-volt batteries also. So I also have, oh my goodness, what is it? 500 and, I don't know, 500 and, let's say 580 amp hours of 12-volt batteries connected here on the 12-volt side of things. And this runs through a 3,000-watt inverter also. Now this being another, let's say another 5 kilowatts or so, 5 kilowatt hours. I haven't, I want to basically feed this in somewhere into this system and transfer that same power that I use for testing of these batteries into this system also. And I'm gonna have to investigate a little bit more. I don't want to use another chargeverter, but what I might be able to do is hook up some kind of relay to allow the chargeverter to flip back and forth between the two systems, and use the intelligence of the automation to allow it to say, okay, pull from this system, flip the relay where it hooks the electrical up over here, runs off of this 300,000 watt inverter, or flip over to this system and run from this one. That's actually a really, would be not too difficult to do, considering I'm going to be pulling from a simple 120 volt line, and usually I'm going to be pulling under 10 amps because I'm pulling it through an extension cord that's either plugged in here or an extension cord that's plugged in there. And an extension cord isn't something that you want to pull near its max capacity at any given time. So I would usually keep those, even though I'm using nice either 15 or 20 amp extension cords, I probably would want to keep those under 10 amps and keep them nice and low where it's safe to use off of both systems. That might be one way to do it, is to put some kind of gate here that allowed this to feed in there. And maybe I could wall that a little bit differently by saying this could go here, this could go here, and we could have some kind of relay or switch that would allow it to feed the charge inverter and for that to go over there. This allows me to keep these multiple systems, and a lot of people would just say, why bother with all these different systems and stuff? And and a lot of, there's a very simple answer. I mean, it would be very easy just to get a couple more batteries for this and just convert them into 48 volt batteries, which I did over here. One of the 100 amp hours over here is what I called the Frankenstein or the bastard battery, which was basically two cheap Chinese 100 amp hour batteries, a lay time battery, and some off-brand, it was some other battery. Anyway, I took those four batteries and put them in series to create a 48 volt battery for the purposes of testing. You know, you hear all this feedback about how batteries, you know, you're not supposed to mix and match them and stuff. To be honest with you, those work just as well as the 300 amp hour EG4 batteries that I have running over there now. And one of them is even a smart battery. The lead time battery is a smart time battery, which hopefully in the future will be hooking up to a Victron system where we can see the monitoring straight out of Victron and see how that part of it works. But that's really not what this is about tonight. But then having this relay from them. So this is one of the crazy ideas that I use to pull some of this power. And this gets me back to the question, which was, why have all these different systems? Why not just convert all these batteries into one 48 volt system and just stick with 1 volt system? And for me, I don't need a 48 volt system on the food trailer, and I need this system to be independent and to be operating all the time. But I want access to the power. I want this to be bigger than 100 amp hours, but I certainly am not going to expand it without having an option to be able to use it when I'm not using the food trailer, or when the food trailer is just sitting at home and getting, you know, during a couple of months of the year where we don't do any events whatsoever. This would be a complete and total waste. And some of those best performing months are going to be those months during the summer when I would get the most power. Additionally, I have the solar panels up on the roof that would be a waste. I have the battery space that would be a waste. And then I don't really want to do a better inverter or more battery space or work on getting more solar there unless I really have a way to get access to that in a more reliable and a more convenient and more consistent basis. But building something that this charge converter could switch from, that's an interesting concept. So I need this one. That's the one reason I keep the 24 volt system. This 12 volt system, I use this one for testing. It does not have to be 12 volt system, but I do a lot of 12 volt battery test, capacity test, and that type of stuff. I don't want to interrupt having the normal work shed where I can't do things. I don't want to have power that's unreliable. I've got freezers and refrigeration out here, and this is also my emergency backup for my house when the grid goes down. Keeping in mind, I've got a grid-tied solar system that has no batteries on it. And with no batteries on it, that means when the grid goes out, so does the 13,500 watts of power and 10K inverter that's connected to my house, and I get nothing out of it. So that's when this would come in handy and allows me to run all those critical loads, which is a lot of where, I started several years ago. And for those of you who haven't heard this story, several years ago, the reason I got involved with solar is that I was here at the house. There was a hurricane coming. It was supposed to be no big deal. When it blew through, we lost power for 10 days straight. When I lost that power for 10 days straight, it kind of dawned on me that I have 13,000 watts of solar panels sitting on my roof doing nothing because they all shut down because the grid shuts down. Now, I could add batteries to that, but when I looked at the cost of adding batteries to the existing system that was professionally installed and performs exactly the function that it was designed to do, I have come to the realization that the solar industry, unfortunately, is a lot like a lot of the other industries in the world, and they're out to make money, not to serve the customers. So I've kind of made it my personal vendetta against these companies to come up with a way to educate the public on how these systems work, how to build them themselves, and how to, when you get a house, how and what kind of system you would want to hook up. On that note, I have launched a new program with a couple of folks around my neighborhood, and I encourage anyone that's within listening distance of this, anyone who's within a few hundred miles of me that has a home solar system, I would like to do a review with you and bring you onto the show as a guest of how your solar system was installed, how it was built, how it's performed, what was your expectations going in, what did you learn while you were doing it, kind of do a review and find out, kind of do a analysis of what solar system you got versus what you thought you were getting, how it's performed the way you would expect it to or didn't expect it to, and what then provide some feedback on what would be better options or could be great enhancements to the system that you have based on my past review of other systems and stuff. So that's kind of the program I'm going to launch to cover this piece for homes. Now, let's talk about some other types of charging that go on and a lot of people use. One that is very common in the van life world is to take DC to DC system charging. And that means that you have your truck or your car, but usually it's a truck or a van, and I'm going to call it a truck. Well, that's a pretty good truck. And you're traveling down the road and you have a solar system either in your RV or some tow along behind you that you're interested in keeping charged up. But in my case, it's an RV. And my RV, let's see if I can do this, make this look right. That's not too bad, huh? Okay, so in my that's what I'm missing here. There we go. So in my RV, if I want to charge this while I'm heading down the road, in the version that I have, and for those of you who follow the channel, you know that my 3,700 watts of power on the roof would charge this anyway, so I'm not worried about it. But a lot of people ask, because this is a much smaller trailer, and they may have 200 or 400 watts of power on the roof, and what they want is when they're driving down the road to take the 12-volt alternator or generator from this and charge that. Now, there's all kinds of devices out that allow you to do things like this. One of the most frequent ones that I suggest is the Victron XS. XS? I think it's the Victron XS. Now that I say that, it doesn't sound right, but that's what I have. Let's just look it up real quick. Victron XS. Yeah, so it is the Victron XS. And this is a 50 amp charger from 12 volt to 12 volt. Now, the only downside to this charger. Well, couple of downsides. One of them is that it's 12 volt to 12 volt only. They don't have one that goes from 12 volts to 48 volts. They don't have one that goes from, and that's why I suggested in van life this is quite popular, because a lot of the van life folks, when they get into a system like this is a 12 volt system down here also, and they use that Victron XS. Now, that allows you to configure it to how much amperage you want to pull and stuff, and you have to be very careful not to pull so much from your truck or your trailer or your car, or that it's made to pull that amount of power, and that you don't stress the alternator, kill your battery, cause yourself all kinds of problems or electrical issues or whatnot. So there are some serious considerations when it comes to doing that. The other thing that I've had people ask about, and this one is probably even more common, and I don't know if it's just the listeners that I have that make this more common, but they have a 48 volt system, and in their fifth wheel it has a 12 volt system. So they install a 48 volt system, and they have a 12 volt system also. Now there is two lines of thought here. One is to use the Victron Orion to convert 48 volts down to 12 volts and eliminate your 12 volt batteries. A lot of the argument against that is that there are surges and things like that that are easily absorbed through batteries, much better than using the Victron. It's called the Victron Orion. And it takes 48 volts and converts it to 12 volts, 30 amps. And I believe they have a 30 amp and a 20 amp, but I have a 30 amp in my fifth wheel. So I charge my solar panels and everything through 48 volts, and then I have the 12 volt ran through the Victron Orion. Now, a lot of people argue that it's better to have a battery there, and I'm not disputing that that is a good option, and in most cases a better option. It did take two of these Orions to completely remove the battery from my system, but we're talking about charging techniques, so I want to give you an idea of the way to do the charging. A good option is to put a Victron charge controller to the 12 volt battery from the 48 volt battery. The nice thing is the charge controller can take the input of this DC power, and it can flow that DC power into that 12 volt battery, safely charging it based on charging profile that you design or build, whether it's a lead acid battery, whether it's a lithium iron phosphate battery, or whatever type of battery it is. You can then use the charge controller and treat this 48 volt input as if the same as if it was coming from PV or it was coming from some other source. This allows that 12 volt battery to remain in existence here to power your internal things like lights and stuff like that, completely isolated from all the other systems. A lot of people are starting to install these big 280, 300, so they're putting in these 300 amp hour or 280 amp hour batteries as their 12 volt system here. And so what this allows them to do is to go out and boondock for days at a time. But with a system like this, you could easily turn on a charge controller that pulls from a 48 volt system and then replenishes those 12 volt batteries in addition to this when you had excess power, and easily maintain those 12 volt batteries without having to worry about it. You can also have a set of panels that only go into the 48 volt and all kinds of crazy things like that. But The idea here is to use the 48 volt battery as input into a charge controller, and the charge controller into your 12 volt battery over here, and then use the 12 volt battery as more of the same way it's always been. It's there to run your stabilizers. It's there to run all of the equipment that you have inside your RV. You allows you to run all of that equipment without the worry of fluctuations or a normal converter. Now, I at one point installed a 48 volt to 12 volt converter that wasn't the Victron Orion here, and it was one of those cheap ones that you get out on Amazon. Let me see if I can find one for you, because this is kind of a funny story. Let's say 48 volts. Let's see if I can turn this on. 48 volt to 12 volt converter. So yeah, this is it right here exactly. So this steps down 48 volts to 12 volts, 20 amps. Now, you would think, okay, if I could install two of the Orions at 30 amps each, and it could absorb all the things, and the converter in the RV, not to be mixed up with the inverter, the converter that converts shore power 120 volts to 12 volts to charge the battery when you're plugged into the pedestal or into the grid, it was a 60 amp source also. So that is why I installed two Orions and why it completely alleviated the need for it. But these devices, I installed 8 of them. And it's still 8 of the 30 amp ones. This one here, actually. 8 of these at supposedly, quote, 360 watts apiece. And that meant that I had 8 times 3, 202.4 kilowatts, or 2,400 watts of 12 volt power. The problem is the surge of just simple surge, like running the stabilizers or the leveling system or rolling in or out one of the rollouts would cause the computer to reboot, and then I couldn't get the stabilizers to start until the computer reset and re-equalized. And as soon as they started again, it would reboot again. So these things are great for running lights and little small devices, but they're not good for charging. They are not good for surges or anything like that, and they're not good for running the big devices in your RV. They simply can't support it, especially when you have more sensitive equipment connected to your RV or your other devices like that. Okay, so let's see what else. All right, so let me see what else I have on the schedule here to go through tonight. I can't believe it's been an hour already. It seems like we just started. But that's kind of 12 volt to 24 volt, 24 volt to 48 volt, 12 volt to 48 volt. There's lots of little chargers that I think could do the job that I'm talking about doing up here. But I really like this relay idea of relaying from the 12 volt system or the 24 volt system into this. It allows me to pull all these different sources in, but it still allows me to maintain all the different systems. And yeah, there'll be some loss, but it should be a lot of fun. Now, let's talk about some standard charging techniques that I used. These are less emergencies type things and more day-to-day type operations. So while I erase this board, I'll give you an idea of what I'm talking about. So what I'm thinking about is during normal operation, when I first got my RV, I would know that I was going to need, the RV would run on probably 20, 25 kilowatt hours a day. And I knew that if my solar system couldn't generate 20 to 25 kilowatt hours that day, that I would come up short of getting my batteries back. And then the next day, I didn't have enough big enough battery bank, and this is before I upgraded my system to have the big DIY battery and increased my kilowatts to around 3 days of autonomy. At this point, I had about 1 day of true autonomy, and that created a real problem in the fact that if I had a bad day of sun, my battery was dead, or it was so weak that the next day it would be hitting zero in the middle of the night. So let me explain to you one of the techniques that I learned. And so the problem was that if I started off at 100%, at the end of day one, I may be here at, let's say that it went down a little bit and then came up just a little bit when the sun came up. And it left me at, let's say, 40%. Now, what would end up happening is the next day after the sun stopped, this would dip down, and sometime in the middle of the night, I would hit 0%. Now, there was a good likelihood that the next day I would have enough sun to recover all of this and put this battery back up at 80, 90%. Keeping in mind, I had 3,700 watts of power on the roof, so I wasn't lacking from being able to generate enough power. I was lacking from being able to store enough power in my bank to outlive the one lousy rain cloud that blew in at 1 o'clock in the afternoon and destroyed a couple of hours of production. So because of that lack of being able to recover it, I had to come up with a way of what is the best way to put energy back in the battery. So one thing I came to is I had an option of, well, let's say this is 7 p.m. to 9 p.m. Usually what I did for a very long time when I first got my system is I would just turn on the grid right here and I would hit the fast charge. And I don't know how many of you are familiar with EG4's fast charge, but it's basically a button. And let me just kind of take you over to it and show it to you. It's basically a button, EG4 monitor. Okay, so it's basically a button here called quick charge. And what the quick charge does, they changed this. It used to be exactly 1 hour of battery charge the end. So for 1 hour, depending on how much I need it, I would just go over into the configuration. And this is configuration. Actually, you know what I would do is I would go into wow. All my URLs are messed up. There it is, Solar Assistant. And I would come over here and I would say, and it's so much easier to find here than it is to find in their app. I would just come in here and say, okay, let's change the configuration. Wow, this changed too. Isn't that nice? Oh, this is all interesting, isn't it? It moved some stuff around on me and I wasn't counting on it. All right, so in this configuration, so it's under config. settings. And I would change the amount of grid charge that I was allowed to the maximum charge current and the maximum grid charge. And you can see here I had it set to 30 amps of grid, but a maximum of 125. And that was so if I did this while the sun was out, that I wouldn't affect getting the PV. I would only affect the grid, and it would just be an additive to what was already coming in. And so this allowed me to hit the fast charge, and if I had that set to a certain amount, then I could get an approximate percentage of what I needed to, or the number, the power that I needed to it happen. So I did this for a very long time. And then I started to think about the fact that if I did it this way, I was taking grid power and I would convert that grid power to battery, and then I would charge the battery. And then the next day I would take this back out and I would discharge the battery, and I would convert this to AC, and then I could use it. So there was a multitude of points here where I was paying what I called the charging tax or the usage tax or whatever you want to call it. I had to pay to convert the AC power to DC power, the DC power to store it, the DC power to unstore it, the DC power to convert back to AC power. And all of these contributed to some losses. And roughly what the percentage was isn't as important as understanding the number of points where things were being lost. So we know there was loss here, there was loss here, there was loss here, and then there was a fourth loss there. Now, this loss was pretty normal because even if it was coming from PV, there was going to be this loss. So even when I brought it straight in from PV, I would have that loss. So really I had 3 additional losses that it was costing me to do this. And what I was interested in is, hey, Mike's Adventures, good to see you. Didn't see your message out there. I don't know how long ago it was, but hi, good to see you. So what I was interested in is what type of method could I use for charging that wouldn't cost me so much in tax? And here's what I came up with. And right or wrong, I'm not sure there is a right way. It's what you're comfortable with. Some people like to just cram the power in there as soon as they have the option. And if there was a rainstorm coming or a bunch of, a hurricane or something like that, then I would just turn the grid on here and tell it to run and charge the battery up. So don't get me wrong, I'm talking about just normal day-to-day operations. So I wanted to eliminate as many of these points as I could. So I knew that if I had PV coming in, that I would change that to AC, and then I could use it. So in this case, I was only paying my conversion tax here, the same one that I had to pay over here. But I also knew that if I had AC power coming in, I could just use it. And I paid no conversion tax. So I began to think that if I took the PV and placed it straight into the battery, then all I had was the charge tax, which if I was going to put the charge into the battery, I was going to pay the charge tax, meaning the losses between what I send to the battery and what it can actually store, what percentage of it can store. Usually pretty high percentage, 98, 99%, somewhere up in that range. Not a lot of losses, but you have some losses there. And then when you pull it out, you lose a little bit more. Then when you convert it, you lose a little bit more. So there is definitely some losses in each of these. But I knew that the most efficient way was to take AC power and just use it. Don't convert it. Don't jump through all of these hoops to get it into the battery. Just use it for the devices while it was being taken from the grid. No conversions, no nothing. And I also knew that the best way for PV power, or the best way to get charge into the battery, wasn't to take the AC battery, AC power, convert it, and then put it in. It was to take the PV power that was already being converted and placed on the DC bus for the inverter to use or to place in the battery. And so to take that and put it here. So what I came up with is in the EG4 app, where I set it when my state of charge got to, let's say, 10%, it would switch to AC power for running devices and DC power and PV power for charging. And it would remain there until the sun came back up and started charging my battery. And when it hit 20%, it would shut this off. And thus I paid no tax on my AC charge, and I paid no tax on my PV charge going into my batteries. And all of the losses that were pertaining to all of this didn't exist. Now, there's a couple of things that you have to be willing to accept if you want to do this. One, in the middle of the night, almost exclusively, is when this switches over to start using grid. Energy rates are usually lower there. That's really good. But energy rates in the morning for a lot of places. Now here in Florida, we have one consistent rate all year, all day long, all morning, noon, and night. But for a lot of people, this 7 or 8 o'clock in the morning, where this is going to be running exclusively on grid, is a peak time and can cost you a ton of money. So it's not ideal for them. This is a much better way to set this window, this charge window at 2 or 3 in the morning, throw the energy into the battery as quickly as you can and shut down. So in the morning, when you have that morning time that where you have that peak hour, you're using all battery power as opposed to that. For me, it was better just to flip it as soon as it got to 10%, flip it over to AC to run all my AC devices and have all of my PV go straight into the batteries. Wait until I noticed that my batteries were being charged up. When they hit 20%, I would shut off the AC and go back to fully battery operated. And what I was basically making the assumption is that this would continue to climb to charge throughout the day and make it up to, let's say, 60%. And it would have shut off here and then started using battery for that also, and taking the PV, converting it to AC and using it, or taking the PV and putting it into the battery. We go back to this scenario. So I really changed one thing. When it got to 10%, I changed my AC usage to use AC out of the wall as opposed to using AC converted from PV or from the battery. It was very effective and the most efficient way that I could find to do it. Now, are there other options? Of course there are. There are places that have free power in the middle of the night. Well, if you've got free power in the middle of the night, then you're crazy if you don't charge in the middle of the night, because there's no reason not to. There are, different things like that, but a lot of it comes down to what are you trying to accomplish? And in this case, I was trying to accomplish reducing the amount of, I call it conversion tax, the conversion tax of this grid power going through 5 conversions before it came back out for use, whereas this went through none and this went through 1. And so it was much more efficient that way, and that's why I was doing it that way. Now, this was kind of a lot of the different techniques that I'm using, but the piece here and the gist of this is that I want to get to the point where I can take all of these systems that I have between the food truck, the 12-volt test system, which is 12 volt, this one's 24 volt, and the shed, which is 48 volt, and put all of that power over here and then use this to run a bit miner and try to take as much of that power as I can and consolidate it down and use it for something that could be, beneficial. Um, anyway, that was kind of what I was thinking for today is the crazy things that we do with solar to accomplish moving the power where we need it. It would be a whole lot easier if I had a single system, but given the circumstances, I never have a single system. I almost always have some test running in some system. I need a very isolated circumstances. I need to know exactly what uh, readings I have on there, and even the test systems that I've built are starting to get more and more complicated because I need to know exactly what the draw is, what the charge rate is, and that type of stuff. So that's what I've been switching to, and that's how I've been doing it. Hopefully that gives you guys some ideas of different ways of charging your batteries, of moving things around, whether you're in van life and want to charge your RV 12-volt battery from your truck or your car or from your van motor, or whether you're in, have a fifth wheel with a 48-volt system and a 12-volt system, and whether you want to bypass the 12-volt battery that's there or charge the 12-volt battery that's there, or whether you're just simply crazy like me and have multiple systems and want to consolidate all the power into one central location so that we can do something with it that is more productive than it just sitting in a food trailer all day and not doing anything. And that's kind of where I'm at now. Then I want to take the ability to take all of those solar panels that I got for since last year, between the $8 solar panels and the $15 solar panels, I ended up with a good, I would say 45 to 50 panels that it cost me less than $500 total. And so with that said, I want to build a reason to hook them all up in a way to use all that power in some meaningful way and not just burn it off, doing this or that. So I figured a bit miner would be a good experiment, and there is certainly an easy way to use a lot of electricity from that, considering that a bit miner runs at 30, and I think I started to do this math for you earlier, but if you consider the fact that the large bit mining systems that I'm talking about a running about 3,030, let's say 3,200 watts. That is 3.2 kilowatt hours, 3.2 kilowatt hours of power per hour. And then that is, if you take that over the period of a day, if we got that running 24 hours, would be 3.224. That is 76 kilowatt hours a day. And that is 30 days a month, 2,304 kilowatt hours a month. As you can see, that is enough power to run a standard size home. And most homes in America, the average home, I would bet that 50 to 60% of the homes use less than 2,304 kilowatt hours a day or a month. So that is a lot of power, but it will make for an interesting project over the next year. Anyway, it's getting late. We've been on for quite a while, and I think that I covered all the subjects. If there's anything that anyone's looking to cover or has any crazy ideas of their own or crazy plans, I'd love to hear about it, and then I'll cover those. If not, then I am going to call it a night. I do want to say that I do want to go back to what we talked about earlier with the number of subscribers that we have, and I do want to celebrate that again. It was basically, I started with it, but I am going to close with it. 17,622 subscribers. Thank you guys for that. The members, we have several new members this month. Thank you to all of my new members and to my persistent and consistent members for tuning in every week and for signing up. I hope you're enjoying the new content. The system that takes the first version of the charge inverter to take the charge inverter from the 28 volt system to the 48 volt system releases on Christmas Day. And I hope you guys enjoy it. And we do have the solar shed we do have the solar class launching the first of the year. I'll leave you with a video on the solar class, what it pertains to, what it is, and how it operates. We do have it at half price for now in the beginning of the year for founding members. We are running out of time for that date. That is going to switch over on January 1st as the class launches, and all the content will become available to each of you members. So hopefully we can get some of you to do that. And I am going to see if I can find the right video. There it is. All right, guys. Have a great day. Thank you for watching. And please consider joining the solar class if that's something that is of good interest for you. And we will see you guys next time. If I can get this to run. And I think this.
Over the last couple of months, I have shown you a lot of different solar builds. We have done everything from a $180 solar shed to the solar shed version 2 that had the solar 12 volt solar system built into it, to an RV 48 volt system, a DIY battery, or even my wife's coffee trailer setup. The one thing I keep hearing over and over from you is that I want to do this myself, but I don't know where to start. So I built something for you. I'm calling it simply the DIY solar class. It's a self-paced, approximately 12-week step-by-step course that shows you how you can design, wire, and power your own solar system the right way, the safe way, and without wasting a whole bunch of money the first time around buying things that you don't need. Learn from my experience. Each week, the curriculum focuses on one of the components in a solar system, either that be panels, batteries, inverters, wiring, real builds, real life situations, real designs, with all the details, with diagrams and videos so that you can follow along. I built this class because I remember when I first started how confusing my first solar system was. I didn't understand amps. I didn't understand volts. I didn't understand wire sizes. I understood electricity a bit, but fuse ratings confused me. Different types of fuses confused me. There was so much information overload that putting it all together with a random selection of videos out on the internet was very difficult. So this class is intended to put it all together. It takes everything that I've learned from dozens and dozens of builds and all the mistakes that I've made along the way, and there have been a bunch of them, and turns it into one complete roadmap that you can follow step by step and get the information you need. So if you've watched my videos or wanted to build your own system, this is how we can do it together. Let me give you an idea of what is included in this class. So you're going to get a step-by-step video lessons for each part of the solar system. Printable diagrams and parts list. Either you can follow them exactly, or we can work together to modify them to meet just your specific needs. We'll do a live Q&A session every other week just for the class so that everyone gets all of their questions answered. I've also included a one-on-one call to go over and to review your designs, or just talk about what your solar system is involved and make sure that you're comfortable and have all the questions you need in that one-on-one setting. Not only that, but you're going to get lifetime access to all this content as I update it as we go along, so that you can go at your own pace, come back at any time to refresh, and when I add new content, you already got it. You can always come back and pick up where you left off, or rewatch the entire course anytime you want. If you've been waiting to build your own solar system, If you're looking for the perfect gift for someone who wants to build a solar system, if you want to put solar in your shed or on your RV or take your house off grid, this class is for you. This is why I made it, to give you that one-on-one help to make sure that you do it right and you do it safely. Founding members right now, between now and the December 31st, get 50% off the class. Starting January 1st, the class goes to full price. So right now, if you sign up, you get it for half price. That's a lifetime membership. You'll never be taken out of the class. You can join today at mattmansolar.com/class or click the links below. Either way, I'm going to keep teaching on YouTube. I enjoy it way too much. But if you want to go deeper, if you want to know exactly what you need for your system, this class is for you. If this sounds like what you've been looking for, head over to mattmansolar/class or just scan the QR code on the screen to grab your spot. Founding members get 50% off through December 31st, and we kick things off on New Year's Day. I'd really love to see some familiar names from the comments inside and help you design, build, and update your system step by step. The link's below, and it's also pinned in the top comment. See you inside. Over the last couple of months, I have shown you a lot of different solar builds. We have done everything from a $180 solar shed to the solar shed version 2 that had the solar 12-volt solar system built into it, to an RV 48-volt system, a DIY battery, or even my wife's coffee trailer setup. The one thing I keep hearing over and over from you is that I want to do this myself, but I don't know where to start. So I built something for you. I'm calling it simply the DIY Solar Class. It's a self-paced, approximately 12-week step-by-step course that shows you how you can design, wire, and power your own solar system the right way, the safe way, and without wasting a whole bunch of money the first time around buying things that you don't need. Learn from my experience. Each week, the curriculum focuses on one of the components in a solar system, either that be panels, batteries, inverters, wiring, real builds, real life situations, real designs, with all the details, with diagrams and videos so that you can follow along. I built this class because I remember when I first started how confusing my first solar system was. I didn't understand amps, I didn't understand volts, I didn't understand wire sizes. I understood electricity a bit, but fuse ratings confused me. Different types of fuses confused me. There was so much information overload that putting it all together with a random selection of videos out on the internet was very difficult. So this class is intended to put it all together. It takes everything that I've learned from dozens and dozens of builds and all the mistakes that I've made along the way, and there have been a bunch of them, and turns it into one complete roadmap that you can follow step by step and get the information you need. So if you've watched my videos or wanted to build your own system, this is how we can do it together. Let me give you an idea of what is included in this class. So you're going to get a step-by-step video lessons for each part of the solar system. Printable diagrams and parts list. Either you can follow them exactly, or we can work together to modify them to meet just your specific needs. We'll do a live Q&A session every other week just for the class so that everyone gets all of their questions answered. I've also included a one-on-one call to go over and to review your designs or just talk about what your solar system is involved and make sure that you're comfortable and have all the questions you need in that one-on-one setting. Not only that, but you're going to get lifetime access to all this content as I update it as we go along so that you can go at your own pace, come back at any time to refresh, and when I add new content, you already got it. You can always come back and pick up where you left off or rewatch the entire course anytime you want. If you've been waiting to build your own solar system, if you're looking for the perfect gift for someone who wants to build a solar system. If you want to put solar in your shed or on your RV or take your house off grid, this class is for you. This is why I made it, to give you that one-on-one help to make sure that you do it right and you do it safely. Founding members right now, between now and the December 31st, get 50% off the class. Starting January 1st, the class goes to full price. So right now, if you sign up, you get it for half price. That's a lifetime membership. You'll never be taken out of the class. You can join today at mattmansolar.com/class or click the links below. Either way, I'm going to keep teaching on YouTube. I enjoy it way too much. But if you want to go deeper, if you want to know exactly what you need for your system, this class is for you. If this sounds like what you've been looking for, head over to mattmansolar/class or just scan the QR code on the screen to grab your spot. Founding members get 50% off through December 31st, and we kick things off on New Year's Day. I'd really love to see some familiar names from the comments inside and help you design, build, and update your system step by step. The link's below, and it's also pinned in the top comment. See you inside.